That's the key, is you can unlock that by having the materials there, by having the biology there that can use that material. That's where I love things like Korean natural farming, because you take normal things like eggshells for water soluble calcium. You take your eggshells, you crush them up, you actually cook them, and that helps to break the molecular bonds when you're cooking them, so that when you put them into a vinegar, whether that's a brown rice vinegar or apple cider vinegar, anything with a mother culture, because it's that mother culture that's all biology, okay? That culture, that biology goes in, breaks the calcium out of the eggshells. It's a natural process. It makes it into a water soluble, so it's easily foliar applied. So instead of the biology having to break calcium out of, you know, the carbon in your soil, or out of the sand, the silt, and the clay, you're spraying it on in a foliar with it being in a water column, easily used and grasped by the biology that's in the leaves, building the new leaves. You take out some steps. We talk, about transport costs for our food. Food coming from, say Australia to Canada. That's a huge distance to travel. Well, just think of it for your plants, where we're talking microbiology moving this stuff around, guys. Like an inch is a long way for a biology. Okay, so if you're doing a foliar spray of the, say the water soluble calcium, then it doesn't have to go through that processing. It's not costing anything to bring that material up from the soil structure. It's there and readily available. That's one of the things with, foliar feeding, and helping the plant and the biology to get everything there when it's needed. Hey, Fried Piper, it's there. Cake in a cup, Australia. Yeah, in the house. It's there. It's easily grabbed. There's no ATP, which is the energy cycle of our plant, of our biology. We don't have to expend that energy. We don't have to put diesel in that big truck going down the highway to bring that calcium over. It's there. You're spraying it right there. And the key is, guys, it's not just the calcium molecules that are there. It's the biology that's broken that calcium out of that eggshell. So it's the biology that knows how to do that job. And as we've learned from Dr. James White with horizontal gene transfer, that same biology just takes off the miner's cap and puts on the construction cap, and all of a sudden it can use that calcium to help the biology that's building that cell. It can step in as an extra workforce, because that's what it's doing. It's working with calcium. It's like a metal worker, okay, can, build something. They can tear something down. They're a metal worker. They can use that metal. That's what they're there. So the biology that's broken that calcium down out of the eggshell is the biology that can use that calcium to build back what it was already been broken down. So these are a lot of little secrets, but the main secret is understanding that S phase of cell division. It's that foundation of all organic life. When you start to really grasp that, and it can take a long time to really go, like, yeah, it really is about the biology, but ingesting it, because we've been told for decades, oh, the plant does this, the plant does that, the plant's making, exudates, and the biology inside the cells make the exudates. It's the biology in that cell that gathers the energy, whether that's from sunlight or from other energies that's available to it, pulls in these molecules, puts them together in a specific way that creates the exudate. It isn't just something that, is all of a sudden thrown together. No, it's specific. As we understand, science has discovered that different exudates are put out through the plant. And I said through the plant, not by the plant. It's the biology that creates those exudates, creates those amino acids by drawing those components together to put out into the soil structure as an exudate to gather materials, because 90% of that exudate that the plant puts out is drawn back into the plant. So in our minds, if you've ever thought of a river system that transports, say, grain down to the coast and then brings other stuff back up to the cities along the route as for shipping and receiving, that's what's happening, guys. Look at it from that perspective of that exudate is, the fuel that goes down. It's the river that goes down, takes some material downstream, but then it comes back up and brings more material back up. Hey, Rhythms, it's thinking of it in those ways that we don't think about, that you really start to understand how this stuff works. It's like the predator-prey model that I keep bringing up, and that's going to be something we're going to be talking more about, because in that predator-prey model, we're going to start introducing the higher life forms, your arthropods, those little bugs you see running around in your compost or through your mulch, those little critters that are running around, breaking that stuff up, making it smaller and smaller and smaller, because a cell only needs, one or two molecules of, say, boron for the healthy cell, but that leaf is too big for the biology to use in that new cell, and it's got to be all broken down. That's where your higher life forms, your worms, your arthropods, moving up into your birds, that cycle has to be built and maintained. And we're going to be having shows on that, specifically, the different bugs that you need to start creating that ecosystem. We had Bohemian on. We showed her garden, what she has done to create that. She's creating that ecosystem. Once we have the foundation built, we want to put the walls up. That's getting the next level of that ecosystem happening, which is the bugs. As we had Claude Roberts on a few days ago, talking about the different bugs that he's seeing. And yeah, quorum sensing is the foundation for all bacterial activity. Yes and no. Quorum sensing can create biology that does not exist in a soil structure. So if you need, you have a tomato plant and you need boron. Okay, tomato plants rely on boron. That's one of the things they need. If there's no boron in that soil structure, quorum sensing happens, and the biology that's needed to create the boron, to mine the boron, say out of the sand silt clay, can actually be developed when the biology gets together and does the quorum sensing. It can create the biology that doesn't exist in that soil structure to go out and mine that soil structure so that that tomato plant can have access to that boron. Higher life forms can be quorum sensed as well. I know that sounds pretty crazy, but in nature, in the progression of life on our planet, that's what has happened is things have been created that weren't there, but were needed. A new type of bee has come in, because bees started, the wasps were first. How the hell did we get the honeybee? That's quite the genetic mutation. But if you take in quorum sensing into the thing and how it's reading all these different genetic profiles, and then it's gathering all the materials together to build new microbiology, it's building new cells. It's creating new options for your car. Oh, I want air conditioning. I want heated seats, or I want air conditioned seats if you're living in California. Okay. It's those options. And quorum sensing can create those options. And all of a sudden you have worms that you didn't have in your soil structure, worms that haven't been seen in decades in your fields. Where did they come from? They weren't just flowing in.